How can superposition exist in multiple states at once? Imagine watching a spinning coin. While it spins, it's both heads and tails at the same time. When it stops, it lands on just one side. This is similar to what happens in quantum mechanics. Superposition is a key idea that explains how tiny particles like electrons or photons can be in more than one state at once. And like everyday objects, which are either one thing or another, quantum particles can be in a blend of states. Think of a light switch that is both on and off until you flip it. In quantum physics, the particle state is described by a mathematical expression called a wave function. This wave function combines all possible states the particle could be in. For example, a quantum bit, or qubit, can be in a state that is a mix of 0 and 1 at the same time. It's like a coin spinning so fast that you can't tell if it's heads or tails. The wave function uses numbers called probability amplitudes to tell us how likely it is to find the particle in each state when we measure it. The higher the amplitude, the more likely that state is to be observed. This superposition only exists as long as we don't look at the particle. When we measure it, the wave function collapses, and the particle chooses one state. That's why in our everyday world, objects seem to be in only one place or one condition. It's the act of measuring that forces the particle to pick a single state. To visualize superposition, scientists often use experiments like the double-slit experiment. When particles such as electrons pass through two tiny slits, they create an interference pattern, similar to ripples in a pond. This pattern shows that each electron acts like a wave and is in multiple places at once, passing through both slits simultaneously. Superposition is what makes quantum computers so powerful. They can process many possibilities at the same time because their qubits are in superpositions. This allows quantum computers to solve certain problems much faster than traditional computers. In simple terms, superposition exists because quantum systems are described by wave functions that combine multiple states. This behavior is very different from what we see in everyday life. It's the foundation of many quantum technologies, including quantum computing and quantum cryptography. Understanding superposition helps us see how the tiniest particles can do things that seem impossible in the world we know.